So you can use LM for modeling, for doing regression. Yeah. When you do simple linear regression, you typically work with a model that looks like this, but where both variables are continuous variables, and then the model will fit a line to your data. But you can extend this slide to all kinds of modeling in R. So you use LM when you have normally distributed data. This is why we checked normality of the data with a histogram. If the histogram shows that the data is not normal, or if you work with data that simply cannot be normal by nature, like counts or percentages or scores, you have to use a different function. You're not going to fit a linear model in that case, but you will fit a generalized linear model. If you want to fit a model that is not linear, you can do nonlinear regression. And for that, there are two possibilities. If you know the formula, so if you know the function that you should use, you know the shape of the model that you want to fit, you know, for instance, it's an exponential, you know that it has an S shape, so you know the shape that you want to fit, you typically use LM with a formula. If you don't know the formula, so you don't know which shape to fit on your data, then you can do Loess regression. And the same thing applies when you want to use LM for comparing groups. There also LM takes the assumption that the data, or at least the residuals, are normally distributed. They should be independent and the groups should have the same spread. Remember? So if this is not the case, if the data is not normally distributed, you again use this GLM function instead of LM. So instead of a linear model, you will fit a generalized linear model that does not take the assumption that the data are normally distributed. When you have dependent data, then you're typically going to use this function from the LME4 package, and you will fit what is called a linear mixed effects model. But this package also assumes that the data is normally distributed. So if it's not the case, you're typically going to work with this package and you're going to perform what is called Bayesian regression. For time series data, you have special models specifically for time series data. And here again, you are going to make the distinction between knowing the formula and not knowing the formula. So knowing the function that you want to fit and not knowing it. If you don't know, you can use the GAM4 package, and then you're going to fit a generalized additive mixed model. If you do know the formula, you can use the NLME package, which stands for nonlinear modeling. And you can use either the LME or the NLME function that will either fit a linear or a nonlinear mixed effects model. For spatial data, so data in 2 dimensions, you can use this package, which will perform Bayesian inference for latent Gaussian models. So, coming back here on my examples, if you want to do something else than fitting a linear model to your data, for instance, you want to do logistic regression, it's not the LM function that you're going to use, but it's the GLM function that you are going to use. So the GLM function will fit a generalized linear model, and it works exactly the same as LM. You need to give him a formula and you need to give him the data set. What is new here is this family argument. What does the family argument refer to? Well, it refers to the distribution that you assume that your data is going to take. So you can work with a binomial distribution, you can work with a Gaussian distribution, you can work with a Poisson distribution if you want to. So these are the most well-known distributions here. So if you want to do logistic regression, it works exactly the same as before. You write your formula, you write your data set, and you specify that you want to use a Gaussian distribution. You save the results in a variable and you can use summary to take a look at the result.